This is chapter 13.6 in the year 1 pure book. I'm going to go through question 3 and the 2 challenge questions in exercise 13F. So, question 3, saying use factor theorem to show that x plus 3 is a solution. That basically just means chuck in x is minus 3 because x is minus 3 would be the solution to this. So we want to say when x is minus 3, we're hoping that we get f of x equals 0, and we just need to chuck in the numbers until we do. So let's go for this. Minus 3 cubed would be minus 27, with the minus outside would be positive 27, that would be 9, 9 times by 4 is 36, we're going to get minus 33, and we're going to get minus 30. That does equal to 0. So, yeah, we're done. We've proved it. Maybe I should do the little box. The clever box. Now we've got to do some polynomial division. You might not be familiar with the way I do it, but I'll talk you through it, how I do it. So, because of that, we know x plus 3 is a solution. We can factorise that out of our original. So, in fact, I'm going to give myself a little bit more. I'm going to write the actual equation on top. So I do it by, what they say is, they do it by inspection. And that is by seeing what we need to add into our bracket to keep the highest order terms happy and then adjusting from there. So, at the start of here, I need to have minus x squared because x times minus x squared at the front here, so x times minus x squared, would give me minus x cubed. Right now, I'm also going to have to do 3 times minus x squared. So right now, I've got minus 3x squared. But at the end of this, I want to have positive 4x squared. So I need another 7x squared to be made in these brackets. So the way I'm going to do that is I need to have plus 7x there. So when I do 7x times by x, that's how I'm going to get my 7x squared. So I've satisfied that. There's nothing else that I'll be doing at the moment that'll adjust my x squared amounts. So let's check what I've got. Now I've got 3 times by 7x, and that is going to give me 21x. I want 11x, so I need to make minus 10x for this to work. So to make that work, I need to put a minus 10 at the end of here for when I do x times by minus 10 to get me minus 10x, and check our final term works. 3 times by minus 10 is minus 30. So that's how we do it by inspection, and it's my favourite method of doing it. And that's it. So that's part B done. There's a lot of short parts in this question, hence factorise it properly. So factorise this properly, I get x minus 5 minus x add 2, just a quadratic factorisation but with a negative in, so just take a bit of care on that and always double check by expanding them again. Hence determine the x coordinates where the curve intersect the x axis. So that's where y equals to 0, so we set this equal to 0, our line above, and we say, well, x is minus 3, x is 5, and x is 2. Be careful not to put minus 2 for that, remember it's minus x plus 2. And then we've got part E. So we can label on our bits and bobs here. That's minus 3, that's minus 2, that's 5. We've got a little bit more work to do with this one because we've got to do it in 2 separate bits. We can't just do it between 5 and minus 3 because it counts these areas underneath as negative when you do your integration methods, and we need to have the knowledge to do it separately and then turn it into a positive number, because you can't have a negative area obviously. So I'm going to do it in two separate parts. So one like this, and then I'm going to add it. So that's basically written out algebraically what I'm going to do. This one's going to be between -3 and 2, and this one, the one on the top, is going to be between 2 and 5. So first, up here actually, I'm just going to integrate my my f of x, just so I'm not cramping up the things too much. I'm going to integrate it up here. So the integration of this is going to be minus a quarter x to the 4 plus 4 over 3x cubed plus 11 over 2x squared. I'm going to go down a line, sorry, minus 30x plus c. I'm going to put a little box around that with an equal sign at the beginning. So that is what is going to be in place when I integrate these. So I'll write that out again. So we're going to have that and that, that and that, and that is going to be between 2 and -3. I'll go a bit to the right, we'll focus just on this, and I'll chuck that out of the corner. And we're going to, sorry about this, we're going to add on the same bit. You find this with these integration questions, you just do a lot of copying out, which is not a bad thing because you don't want to be doing it all in your head and making mistakes. And we're going to do that between 5 and 2. To save you the witnessing me substituting in some numbers, I'm going to tell you what my substitutions get me, and you can double check to see if I am correct. So in this case, I am going to get minus 94 over 3 subtract 333 over 4. In this bracket, when I do it substituting in 2, subtract substituting in -3. And then I'm going to, for this one, I'm going to get minus 25 over 12 when I substitute in 5. And we've just done it before when we substituted in 2. Good thing is you don't have to, these are the same pretty much all the time, so you don't have to do it again. So this brings me to 117 over 4. This brings me to minus 1375 over 12. However, when we go and do the sum, we're going to take the positive of that. The only reason it's negative is because it's underneath the curve. So we want to take that as a positive and add them together, and you are going to get 863 over 6, or 143 and 5/6, or some decimal that we don't care about because we like fractions. So the challenge questions. These challenge questions were quite challenging, true to their name, which is nice. This one in the book, they started doing some working out when you can do a lot of this just by thinking about graphs. First one, we got to figure it out. So y equals to fx, I'm going to expand this to be 3x minus x squared, and then I'm going to oh yeah, we know that the graph's going to have solutions of x equals 0 and x equals 3, so it's going to be bounded between 0 and 3. And when we go ahead and integrate this, we get 3 over 2x squared minus a third x cubed plus c between 3 and 0. And when we do that, we get 9 over 2 subtract 9 over 2 plus c, subtract c, So it just leaves us with 9 over 2 as the area. Let's have a look, and I've got some stuff prepared on a GeoGebra file for us to have an investigate with B, C, D and E, to do this without having to do any calculating. So let's have a go at this. So right now I've just got x squared minus 4 drawn, because it'll serve the purpose of what I'm trying to prove here. And I've called it f of x, so f of x equals x squared minus 4. I'm going to type in what our first one was, so 2 f of x. And we can see, we're concerned about the area underneath here as well. We can see, you know, when you put 2 out before the f, it's going to double the coordinates of the y-axis, so it's going to double from minus 4 to minus 8, and it actually doubles the area. So if we go back to our whiteboard, it's going to double the area, so the area is 9. So how about y equals to a f of x? If 2 doubles it, what happens when we've got a? So I'm going to delete that one, and I'm going to type in a f of x. It's going to give me an option for a slider, and that's so I can change the value of a. So right now it's just f of x. Right now it's 2f of x. Right now it's 3f of x. It's going on off our page. And it's going to be 0.2f of x. Obviously turns by a decimal, it'll be smaller. And then we get into some negatives, which we're not going to concern about. But you can see it just gets larger as the numbers get bigger, smaller as the numbers get smaller, and it's proportional to what the number of a is. So this is just going to be a times larger, and if it's a decimal, that will make it smaller. So the area will just be 9 over 2a. How about D? Y equals x plus a. So I'm going to delete this one, and I'm going to plot that. So f brackets x plus a. We can see it doesn't change the area at all. It just, oh, let me delete this one. It just shifts it. So yeah, so if it's x plus 2, x plus 0, x plus 1, etc., it never changes it. It's just going to shift, so it stays the same. So again, 9 over 2. And then finally looking at E, I'll squeeze it in down here. Y equals f ax. So this is where a is inside the brackets this time and not outside. So this is going to be affecting our x value. So let me delete this. So we're going to have f brackets ax. So this would be f brackets 2x. We can see it's halved our x value, so it's actually halved our area. I can do it up to 4, maybe another nice point. We can see this has gone to the x values at a half, so it's split our area into a quarter. So it's actually just going to be a times smaller, and if I take it to 0.5, if I possibly can, oh, I had it, there we go, we can see they've doubled, because when you divide by half it's the same as times them by 2. So we can say, well, this is going to be a times smaller, so it's going to be 9 over 2a. A has joined our division of this, so it's kind of like this, and then we keep flip change, so it's gone to 9 over 2a. So that was a quick way of doing all them questions without particularly having to go through the process each time. Okay, this is a bit of a long one, this is a bit of a hard question, I think. But let's go for it. And hopefully I don't bore you too much or bore myself too much going through this one. So, let's just start off. We have this function here, and we can find out b quite easily because it's just one of the solutions. It looks like that's going to be positive 1. However, this is going to be negative 2 here, but that isn't the value of a that we're integrating between. So we've got solutions of x equals 0, x equals 1, x equals minus 2. I'm going to mark them on minus 2, 0, and 1. And it says the shaded areas above and below are equal. So this equals to this, and that's going to be quite important in this first or second question. We shall see. So let's just start off answering it really. Let me get my working up in front of me. So first of all, I expanded these brackets because I thought if I'm going to be integrating it, I need it to be expanded. So when I expanded the brackets, I got to that. So I know, let's colour code this a little bit. This is going to be my green working out, and then I'm going to do the black, actually red working out for this. So between O and A, we don't know what A is. I'm actually just going to call this X at the moment. So between 0 and X, we're going to differentiate the function, and that is going to be my green region here. And then when I go for my red region, that is going to be integrated between 1 and 0. And that's going to be my red region. We know that they're going to be equal. However, this green one is going to be positive, and when we get this red one, it's going to be negative. So to reverse that, I'm going to pop a negative sign in front of there, because I'm going to get a negative value out of this. Because it's underneath the curve, and I'm just going to change it to be a positive value. But if I want to set up an equation early, I'm going to have to take that into account. So let's go and do our red line first, because we can. Okay, so our red line. I'm going to do the working up here. Just to keep it nice and neat, I'll do the working a bit to the side. So, going to integrate this. What does that give me? Okay, well that integrates to quarter x to the 4 plus a third x to the 3 minus x squared plus c, and that's between 1 and 0. And then substituting in 1, so that's going to give me a quarter plus a third minus 1 plus c. And we're going to subtract 0 plus c. C's cancel. And then when we do this, quarter plus a third, subtract 1, we're going to get minus 5 over 12. So we know the area equals to 5 over 12. So that would be minus 5 over 12 because I've got the minus there. This is going to equal to 5 over 12. So go to my green. Between 0 and x, it's going to be the same integrated function here. So we need to go ahead and kind of ignore the red for now and go ahead and complete our green working out to find out the area of this in terms of x. So substituting in 0, it's just going to give us plus c. Subtract, well, if we substitute in x, it will still actually just exactly be what we have here. The c's cancel. Remember to apply the negative to everything, so it's minus x to the 4 minus a third x cubed plus x squared. And that equals to 5 over 12. I'm going to bring it back in. Let's times everything by 12. We've just got an equation here now, so times everything by 12 minus 3x to the 4 minus 4x to the 3 plus 12x squared equals 5. Let's take everything over to this side because we want a positive version of x to the 4. So 3x4 plus 4x cubed minus 12x squared plus 5 equals to 0. Have a look back at the question. We've done a lot of work and we haven't looked at what we've actually been asked to do. We just want to show that the x coordinate of A, which is this x we've plugged in here, so we're on the lines of showing something to do with this, can be rearranged to look like this. So right now we've got it equal to 0. They've got x minus 1 in there. That's showing me a hint of kind of using factor theorem to show that 1 is a solution. Factor theorem. So let's try x equals to 1. Factor theorem is basically chuck a number in until you get your thing to equal to 0. So 3x to the 4 is just 3. Don't know why I'm writing that. 3. If I substitute 1 into here, I get 4 minus 12 plus 5. 3 plus 4 is 7 plus 5 is 12. Yes. So we can say x minus 1 is a factor. So let me in fact write out what we started with again. So I'm going to factorise x minus 1 out of this. Out of that. So I do this by inspection. You might do it through polynomial division, which is fine. I think I just prefer this method and it's the one I'm comfortable with doing. So that first one's a simple one for me. I know I need to do x times by 3x cubed to get 3x to the 4. So here times by here to get this. Right now, from my other multiplication of minus 1 times by 3x cubed, I have minus 3x cubed. I want positive 4x cubed, so I need another positive 7x cubed, and I need to get that through doing x times by something. So I'm going to do that by doing x times by 7x squared. Let's rub this out, we don't need this anymore. And again, let's have a look at what we have. So checking again this minus 1. So right now I've got minus 7x squared. So I have minus 7x squared. From the question you can see that I want minus 12x squared. So I need another minus 5x squared. And I am going to do that by doing x times by minus 5x. And you can always just go through that a little bit slower and double check I've got everything so far. And then right now I've got a positive 5x. I want to have, so I have positive 5x. I want no x's, so I need a minus 5x. And I'm going to do that by doing x times by minus 5. And double check your constant at the end still works. Minus 1 times by minus 5 gives me positive 5, so yes, that definitely works. I then want to do factor theorem again. But I'm just going to do factor theorem on what's in my second bracket. And from the question, it seems pretty clear that I'm going to be doing x plus 1 because we want an x minus 1 squared in there. We want another x minus 1 bracket. So I'm going to check x equals to 1. So 3x cubed when x is 1 is just 3, 7x squared, 5x, 10 minus 5 minus 5. So yes. So x minus 1 is a factor. So then I'm going to factorise out x minus 1 from this. So by inspection, I'm going to do it a little bit quicker this time. I need 3x squared. Right now I've got minus 3x squared. I want 7x squared, so I need another 10. So to get that, I'm going to have positive 10x here, because it's going to times by this x there. Then I've got minus 10x. I want minus 5x, so I want another positive 5. I'm going to have positive 5, because positive 5 times by x will get me that. And my constant checks out. 5 times by minus 1 gives me minus 5. So, altogether, so right now we know that that equals to what we've just factorised it from. All of that equals to that. And that line you can see is here. So replace this with what we've just found. Remember the x minus 1 at the front from here. You can put them two brackets as a squared. And then scroll up to your question. And finally see that we've done it. And we know that we can set it equal to 0 because we've been setting it equal to 0 throughout the question here. I've just been skipping it out because I've been a bit rubbish. Okay, so part B. I'm going to copy and paste the question into a separate little section so we can see. So I don't have to keep scrolling up that far every time. Oh, it even keeps my little annotations, that's amazing. So, find the exact coordinates of A and interpret the geometrical roots of this equation. So, taking this equation here, we know we've got roots of x equals 1 and x equals 1, because we've got a repeated root. Then I'm just going to do the quadratic formula on what's in my other bracket to solve that equals to 0. So I'm going to do the quadratic formula on this. I'm not going to do the quadratic formula in front of you, I'm just going to tell you what I got when I did it. So when I did the quadratic formula, I got x equals to minus 5 plus root 10 over 3, and I got x equals to minus 5 minus root 10 over 3. Just for a bit of context, this one would be equal to minus 0.61, roughly, and this is roughly equal to minus 2.7. So having a look at our graph, x equals 1 is going to link, so when it says kind of interpret geometrically the other roots of this equation, I'm going to interpret the roots of this one right now. So these roots, these are exactly on x equals 1, and if I put x equals 1 into our equation, we would find that we would get 0 just because this bracket would straight away turn to 0. So these are going to be x equals 1 and y equals to 0. This is going to be the point B. That's what them roots represent. This one here, minus 2.7, well, this is, minus 2.7 would be somewhere over here. That's definitely not the coordinate of A, and when we substitute in x into our original equation, which is this one up here, so when we substitute into y equals to x, x minus 1, x plus 2, sorry, I should have said you should have substituted this one into that original as well, you'd still get 0. When we substitute it into that, we find that y equals to something pretty gross as a third, but roughly as a decimal, just because I think it gives a bit more context, is this. So that's actually going to be somewhere a point kind of down here. We can see where this graph's going to continue. So geometrically, this is definitely, or defo, not the point A. We can say that confidently just by looking at the placement of it on the graph. Then let's have a look at this one. So minus 0.61. Looking at the graph, if I pull this back on top of all of this, it seems like this could make sense. Minus 6.1 is between 0 and 2. Let's have a go at finding this. So when I substitute this into our x minus 1, x plus 2, I'm going to substitute this in. I get minus 80 plus 37 root 10 all over 27, and that roughly equals 1.37. So we've got a coordinate, roughly, of 0.61, 1.37. It's a negative x value and it's a positive y value. It seems like that's definitely going to be our coordinate of A. So we can say, well, the root of, so this root here is going to be our coordinate A. So we can say A has the coordinates minus 5 plus root 10 over 3 and minus 80 plus 37 root 10 over 27. You'd always put the exact thing as your answer. This bit was just to get some idea of whereabouts it is on the graph, because I don't think anybody knows exactly where minus 80 plus 37 root 10 over 27 would be in a quadrant. Okay, that was a bit of a longer one. I am tired. That's that. Thank you.